Hello, today I start recording the videos about the number theory, and the first one will be Chinese Remainder Theorem, which tells us that we can always find the number x which equals a1 mod m1, a2 mod m2 up to an mod mn if we are given n coprime numbers, which means that GCD of mi and mj always equals 1 for every I and j in this range from 1 to n. To prove this, for every number from 1 to 3 up to m1 times, m2 times, up to mn, for each number correspond n tuple r1, r2, up to rn. There r1 equals remainder mod m1. Similarly for r2 up to rn. Now we need to show that these all n tuples will be different. And contradiction of this is that if we are given two numbers a and b whose n tuples are same, what can we say? These tuples are same. If we subtract these two numbers, a minus b, tuple of this number, or b minus a, it has no matter, will be correspond to 0, 0, 0, up to 0. This will be length of n. Because all the numbers in the tuples will be the same, if we subtract, it will become 0 for every mi, and this means that this number is divisible by m1 times, m2 times, up to mn. And clearly this is impossible because both of these numbers must be less or equal to m1 times m2 times mn, and if we subtract any of this number, absolute value of this number a minus b, absolute value of a minus b is always less than m1 times m2 times up to mn. So we have proved that all these tuples are different, and if we know that all these tuples are different, how many possible choices do we have for tuple? For r1 we have m1 different choices from 0 to m1 minus 1. For r2 we have m2 different choices, and for rn we have mn different choices. So in total we have m1 times m2 times mn different choices. And what does this mean? That if we know that none of these tuples are same, so if someone tells us tuple a1, a2 up to an, we can always find number x which will be in the region of from 1 to m1 times m2 times mn, whose tuple will be corresponding to the a1, a2 up to an. If this is from 0 to m minus 1, m1 minus 1, this must be from 0 to m2 minus 1, and last one must be from 0 to mn minus 1. Here we have used the fact that all these GCDs are different, are equal to 0, because LCM of these numbers m1, m2 up to mn must be their product, and absolute value must be less than m1 times m2 times mn. So if we found such x that its corresponding tuple like this one, then we can conclude that x equals a1 mod m1, x equals a2 mod m2, and x equals an mod mn. And this was what we wanted to show, so we have proved Chinese Remainder Theorem.